Hey, how's it going? Today is August the 11th. We are going to be taking a look at what we're going to be doing today. So, August 11th, you'd go here and click. I hope everyone's doing well. It should take you to a lesson page. You have the attendance. You'll click here, you'll take the attendance, and then you'll exit out of it. Today's goal is that students will estimate a square root as a decimal. Students will place numbers on a number line. This video will be changed where it says August the 11th here. If it is not, please email me if it's ever the wrong date here. Please watch the video. So the teacher, who can tell me what 7 times 6 is? It's 42. Very good. And who can tell me what 6 times 7 is? Same student, it's 24. Hopefully you get that. 7 times 6. They flipped them around, so she flipped around her answer. Your attitude, not your aptitude, will determine your altitude. So what that means is if you approach things with a positive attitude, just because you want something doesn't mean that you're going to get it, but your attitude can sometimes determine how far you get. So make sure you have a positive attitude. All of this is new to all of us. If you have questions, please reach out to me at my email at esutherland@acsc.net. Here is today's PDF. I really recommend pulling this up when you're taking your quizzes. There's a lot of information on here that will take making your quizzes super easy. So bring those up. You have a assignment today here, and click that and take that assignment. It is looks like worth 10 points, so make sure you take that. And then here's today's lesson. Today's lesson is August 11th, 2020. Some of this information may seem like a review, and some of it may be new information. The only thing that I really have for you guys is the definitions. And so, like, we've been given these natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Today, we're just going to go over 2 of them, and we want to focus more on rational, irrational, and I lied, we're going to go over 3. So, any number you can write as a fraction. So, decimals that can be written as a fraction either end or they repeat. If that's a rational number, then an irrational number has to be a number that cannot be written as a fraction. And decimals that can't be written as a fraction end and they do not end and they do not repeat. The most common way you'll see this is square roots that are not natural numbers. So in other words, the square root of 9, for example, is 3. Right? That's not going to be a irrational number. However, the square root of, let's say, 27 is an irrational number. Pi is also another way. All of those numbers, rational and irrational numbers, are real numbers. A real number can be placed on a number line. All of these numbers can be placed on a number line. Understand that natural numbers are whole numbers are integers are rational numbers are real numbers. Irrational numbers are also real numbers. Perfect square, here's a chart showing you the perfect squares. You'll need this for your assignment today. I would suggest pulling it up on a PDF so you have access during your assignment. And then a square in mathematics simply means that it's going to be any number times itself. The other thing you need to know is a square in mathematics means that your answer will always be positive. Square roots or radicals, they're often indicated, or they're indicated with this sign. Sometimes the sign doesn't have the top piece, just so we're on the same page. It'll look like this. It's still 2. Kind of looks more like a check mark than it does a radical sign. You'll need this as well for your assignment today. A Square root in mathematics means basically what number times itself will equal the number underneath the radical sign. So you'll notice here 100, the number times itself that equals 100 is 10. 10 times 10 is 100. So the one problem that you have with radicals is not only that, but negative 10 squared is also equal to 100. However, for this class, we will mainly use the positive. So for every radical or square root, there is actually two answers, positive and a negative version of it. We're going to focus on the positives for this class unless I otherwise indicate that I want the negatives. Like I said, very rare cases that we'll want the negatives. Square roots that are not perfect. So the square root of 245, for example. The easiest way to do this is just pull out your calculator, type in square root 245, and you're going to get this here. One thing that you should do is listen to the directions. If it says round to the nearest tenth, round to the nearest tenth. If it says round to the nearest whole number, round to the nearest whole number. So the nearest tenth would be 15.6, and then we're going to look at the 5. Because that 5 is 5 or higher, we're going to make this 15.7. This is for the nearest tenth. If it was 4 or lower, we would have left it at 15.6. For a whole number, 15.6 is what we need to know. We look at the 6, and because that's 5 or higher again, we're going to round it up to 16. Had it been the number 3, if it was 15.3, we would have left it at 15. And then you have to place those on a number line. So like here is like you're just given this decimal, place it on a number line. First of all, you're going to go find where the 44 is in this case, line. And since it's just a little past 44, you're just going to go a little bit past 44. You're estimating where it goes. Doesn't have to be perfect. If someone would have put it right there, I would have counted that right too. This is an estimate. And then for the square root, you're going to need to calculate what that is on a calculator. And then it says 40.7, so we're going to find 40. And since 40.7 is closer to 41, we're going to be a little bit before 41. All right, that is today's lesson. If you have any questions, by all means, please send me an email. I will try to return it as fast as possible. When you're placing a decimal, remember, or a non-perfect square, it is necessary to estimate to the nearest tenth or whatever the directions indicate. Once you have the estimation, you need to decide what numbers is it going to go between on the number line, and is the estimate, and then estimate its placement between the two numbers. So for example, we looked at, okay, 40.7 falls between 41 and 40. So notice how I got those lines there, and then 40.7 has got to be between there. Have a good day.